Hello, today I will speak about rational function, all types of asymptotes. Vertical asymptotes occurs when denominator equals 0 and numerator not equal 0. When we look at f of x equal p of x over q of x, and q of x, when it's equal 0, the function will be not defined. Example number 1, f of x equal 1 over x minus 2, and I will take x minus 2 equal 0, then x equal 2. When x equal 2, I will substitute instead of x here in numerator, instead of x2, the numerator will be 0, but the denominator continue with a number. It's not a 0. Then I will find the function has a very vertical asymptote when x equal 2, because the numerator will be 0 but not the denominator. Example 2, f of x equal x plus 4 over x minus 3, and x minus 3 equals 0, x will be equal 3. Because when I move 3 to the another side, I will change the sign. And then the function has a vertical asymptote when or at x equal 3, because when I substitute instead of x3 here in the numerator, the numerator will be 0, and when I substitute instead of x here 3, the denominator will be 7, and because of that I have a vertical asymptote. I continue with another example. A function can have more than one vertical asymptote. The function can have more than one vertical asymptote. The denominator is 0 when, if I take this example, f of x equal x divided by x minus 1 by x plus 2, and I will take x minus 1 equal 0, x equal 1, and the denominator is 0 when x equal 1. When I substitute instead of x 1 here, 1 minus 1 equal 0, and 0 by the whole parentheses here, it will be 0. The numerator will be 0. But when I substitute instead of x 1 here in denominator, and it will be a number, not 0 here. And when x plus 2 equal 0, x equal minus 2. And the same here, when I substitute instead of x here in this parentheses, I will see minus 2 plus 2 equals 0. And when you multiply 0 with another number or another parenthesis, it will be 0. And I see when I substitute instead of x here minus 2, the denominator is a number, not a 0. then I will say it will be two vertical asymptotes in this example. The denominator is 0 when x equal 1 and when x equal minus 2. The functions have two asymptotes at x equal 1 and x equal minus 2. A function can have more than one vertical asymptote, but it can have at most one horizontal or slant asymptote. Example 4. F of x equal x over x minus 1 by x plus 1. If I take x minus 1 and equal 0, x will be equal 1, because when I move minus 1 to another side, we must change the sign. It will be plus 1. And another x plus 1 equals 0, x equal minus 1. And when I substitute x equal 1 in the numerator, it will be 1 here. The same when I change x minus 1 instead of x in the numerator, it will be a number, not a 0. But when I substitute 1 in this x minus 1, instead of x, it will be 1. 1 minus 1 equals 0, and the whole numerator will be 0. The same if I change x with minus 1 here, it will be minus 1 plus 1, it will be 0, and the numerator will be 0. When I have a number at the denominator, not 0, but I have 0 at numerator, it will be, the function has asymptote. And this function has two asymptotes, and one of them, the denominator is 0 when x equal 1 and when x equal minus 1. Therefore, the function has two asymptotes at x equal 1 and at x minus 1. Horizontal asymptote. Denominator degree larger than numerator degree, y equals 0. When the denominator and numerator have the same degree, ratio of leading coefficients. Third, numerator degree larger than denominator degree, no horizontal asymptote. Example 1. F of x equal 5 over x. We study the behavior of the function when x go to the infinity and when x go to the minus infinity. If x is very large, for example, x equal 1000, f of x, I will change x with 1000 here, and I will get 0.005. This value is very close to 0. This value is very close to 0. If x is very small, for example, x equal minus 1000 and f of x equal 5 over x, I will change, instead of x minus 1000, f of x equal 5 divided by minus 1000, and I will get minus 0.005. This value is very close to 0 because the function approaches 0 when x becomes very large or very small. We'll say y equals 0. This is a horizontal asymptote. Y equals 0, and this is a horizontal asymptote. As x increases or decreases without limit, the value of the function gets closer and closer to 0, but it never actually reaches 0. Important note: the function does not touch the line y equals 0. That is why y equals 0, called a horizontal asymptote. If the function has same degree on the denominator or numerator, so we take ratio of leading coefficient. And in this example, if we look, f of x equal 2x plus 1 over x minus 3, we have the same degree in the denominator and in the numerator, and we will take the coefficient of the denominator or the ratio of the coefficient. And this here in the denominator I have 1x, so it will be horizontal asymptote when 2 divided by 1. So the function has horizontal asymptote when y equal 2. Slant asymptote occur when the degree of the numerator is exactly 1 degree greater than the degree of the denominator. Slant asymptote here, we can divide it along division here to find the slant asymptote. How many x in x squared? It will be 1. 1x, x by x squared, and this plus we change to minus because we will use the subtraction, and x squared minus x squared, it will be 0, and I will write minus 1. The slant asymptote equal y equal x, and I can write the answer of the division like that: x squared minus 1 over x equal x minus 1 over x. And this, if I look at this function, and I think it has a vertical asymptote also, and if we x equal 0, it will be the function will be not defined when undefined when when x equals 0. But when I substitute 0 in the numerator, it will be 0 power 2, and it will be 0. I have minus 1 here, and this means that I have vertical asymptote when x equal 0. So slant asymptote when y equal x, this slant asymptote, the function has slant asymptote when y equal x, and vertical asymptote when x equals 0. No asymptote, we look at this example, I must read this because it's important. Slant asymptote occur when the degree of the numerator is exactly 1 degree greater than the degree of the denominator. Slant asymptote here when y equal x. When we look at the function, we see this degree x square are higher than degree of the denominator with just one, because this x power 1 and this x is power 2, and 2 minus 1 is 1. So slant asymptote occur when the degree of the numerator is exactly 1 degree greater than the degree of the denominator. So we have slant asymptote when y equal x, when vertical asymptote when x equal 0. No asymptote, just a whole example. If we look at this example, f of x equal x square minus 1 over x minus 1, and I can write this function in another way: x minus 1 by x plus 1 divided by x minus 1, and x minus 1 disappear with x minus 1 here and I just have x plus 1, f of x equal x plus 1, and there is a whole not asymptote. This is our not asymptote. Example: f of x equal x squared over x minus 1, and in this function, the function has both slant asymptote because the degree of the numerator larger than the degree of the denominator, and it has vertical asymptote. We can take x minus 1 equals 0 and x equal 1, and when I substitute 1 at the numerator, it will be 1 here, not 0. But when I substitute 1 instead of x here in the denominator, it will be 1 minus 1 and it will be 0. That means the function has vertical asymptote when x equal 1. slant asymptote because the degree is higher at the numerator than the degree at the numerator at the degree at the denominator, so we can divide it like a long division, x squared divided by x minus 1, and how many x is in x squared is just 1. X by x equal x squared, and x by minus 1 minus x. And I will change the sign here because I will so I will do a subtraction. X squared minus x squared equals 0, and I have plus x, and I can continue division because x and x here and x here have the same degree, and how many x is there in this x? It's just 1. 1 by x equal x, and by 1 by minus x equal minus 1. 1 by x equal x, and 1 by minus 1 equal minus 1. And I will change the sign. X minus x equals 0 plus 1. And the slant asymptote, the equation or the function has slant asymptote when y equal x plus 1, and I can write the result of the division like that: x plus 1 plus 1 divided by x. This is the number which is remain x minus 1. So the slant asymptote, the function has slant asymptote when y equal x plus 1, and vertical asymptote when x equal 1. The last example. F of x equal x squared minus 4 over x minus 1, and if I have vertical asymptote, x minus 1 equal 0, x equal 1, and if I substitute 1 instead of x here, it will be 1 minus 1, and the denominator will be 0. But when I substitute 1 instead of x here, it will be 1 squared, and it's 1, and the numerator, it will be minus 3. This is a number not as 0. It means I have the function has a vertical asymptote when x equal 1, and because of the degree the numerator are larger than degree of the denominator, so it's x squared here, and it's x power 1 the denominator, so I can divide a long division. It will be a slant asymptote also here. How many x is in x squared? It will be 1. X by x equal x squared, and x by minus 1 equal minus x. And I will change the sign. X squared minus x squared equals 0, and minus 4 plus x minus 4. And I will continue with division because I have the same degree here. How many x in this x? It's just 1, so plus 1. 1 by x equal x, and 1 by minus 1 equal minus 1. And I will change the sign. x minus x equals 0 and minus 4 plus 1 equal minus 3. The function has a slant asymptote when y equal x plus 1, and the result I can write it like this: x plus 1 minus 3 divided by x minus. I can write this in just maybe more clearly. I hope it was a good lesson for today, and we will meet in a new video. Bye bye.